This is Unit 1, Block 1. We're starting this first day here with a basic review of functions and function notation. So recall, when we say f of x equals y, instead of referring to the function value as a y value, we're referring to it as f of x, where you input an x value and it outputs y equals f of x. So thinking about it on a graph, you would input the x, and instead of thinking about the y's as the output, we want to think of f of x's. Plug in the x, the function of x is the output y value. So for example, if we had the function f of x equals 2x minus 4, if I were to ask you to find f of 3, you can compare that back to f of x is y. You notice here that inside the parentheses where we usually find the x, I've replaced the value inside the parentheses with 3. In other words, x is 3. So we're saying evaluate f of x equals 2x minus 4 when x equals 3. So I go to my expression 2x minus 4. I replace x with 3. And I evaluate f of 3, which is 2 times 3 minus 4. So it's 6 minus 4. It's 2. F of 3 is 2. That should be clearly understood to be different than asking to find or solve f of x equals 3. Again, if you compare this back to the notation f of x is y, notice this time we see the value inside the parentheses is the input x, but I do not have a given value for x. X is still the variable x. This time I've replaced the y with 3. So when I say that f of x is 3, we're saying y is 3. The f of x is 3. The output value is 3. So if we know that f of x is 2x minus 4, and I'm telling you that y is 3, f of x is 3, we need to replace the entire f of x, the y value, with 3. Now we have an equation we need to solve for x. So we add 4 on both sides. We divide by 2 on both sides. We get x is 7/2, or 3.5. On the next page, again, more work and thinking about function notation, and now we're going to put some of it into context. Here in example 1, we say C of T billion dollars is the value of the cumulative capital investment in the cell phone industry. T is the number of years after 2000. So let's first just quickly make sure we understand what we mean by C of T. This is similar to f of x is y. C of T, just different letters. They're telling us here that T, the thing inside the parentheses, is the input, just like you would plug in x to f of x. C of T is like your y value, is your output. So when we see C of T, T is the input, C of T is the output. And in this case, they told us T is the number of years since 2000. So if T equals 0, that means the year 2000. If T equals 1, that means the year 2001. C of T means the value in billions of the cumulative capital investment in cell phone industry. Just abbreviating all that mess there. So it says write a sentence interpreting the real-world practical meaning of the statement C of 9 is 285.1. So again, we should compare that back to the C of T. C of T is 285.1. They're telling us here T is 9 and the C of T is the 285.1, and we already stated above that when we see a T, we know it represents the number of years since 2000. When we see a C of T, it represents the value in billions of the cumulative capital investment in the cell phone industry. So putting that together here, 9 is number of years since 2000. So they're talking about the year 2009. So in 2009, the 285.1 is the billions of dollars. So, in 2009, the value of the cumulative capital investment in the cell phone industry was $285,100,000,000. Part C asks us to do it backwards. Write a function notation statement for this sentence. In 1990, the cumulative capital investment in the cell phone industry was $6.3 billion. So in 1990, we need to ask ourselves, what is the value of T? Recall T is the number of years since 2000. So this is 10 years before 2000. So T would equal negative 10. And C of T is in billions of dollars. So C of T is 6.3. So you would get out of the function 6.3, and it represents $6.3 billion. So as a math statement, we would write C of negative 10 equals 6.3. In example 2, we've been given a graph and a formula for a function. It says the population of a town is given by P of T equals 85.2 times 0.924 raised to the T, where T is the number of years after 1950. P of T is the population of the town in thousands, and here is a little sketch of the graph. So when I see this formula, you see that we are inputting T, and we are outputting P of T. And they told us T is number of years after 1950. So along the input axis, we have T, which is number of years after 1950, and we see the scale given in the problem here. We have 10, 20, 30, so 10 years after 1950, 20 years after 1950, and so forth. And along the output axis, we have P of T, which is the population of the town in thousands. So meaning 20,000 people, 40,000 people, 60,000 people, and so forth. So it asked us in Part A to label the graph, which I've done. I labeled the variable T and P of T, and I labeled the meaning of the variables. So Part B says use the graph to estimate the solution to P of T equals 40. Again, if it helps you, if you're still just learning function notation, it might help you to write f of x is y. They are telling me here the output value, the y value is 40. On a graph, that means the height of the graph is 40. So we need to go over to our graph, find a height of 40, which is this here. I'm going to draw just a little horizontal dashed line over at a height of 40. I see that my graph, P of T, will hit a y value of 40 approximately there, and we're estimating, looks like that happens at about T equals 10. So P of T equals 40 when T is approximately 10. I'm using a little wavy equal sign because it is an estimate. Write a complete sentence to interpret the real-world practical meaning. So T equals 10. T is number of years after 1950. So it's saying in 1960, and P of T is 40, which is the population of the town in thousands, so that's 40,000 people in town. So in 1960, there's 40,000 people in the town. Part C says to use the graph to estimate P of 30. Again, if it helps, you can always write f of x is y underneath. And comparing here, it's an input value, like they're giving us the x value. The input value is 30. So the t is equal to 30. We need to go to the graph, find when t is 30, and then estimate the value of y. So t is 30 here. I'm going to make another little vertical line at t is 30. I see it intersects my graph around here. And I'm going to estimate the height of the graph at that time. Just going to take that right on over. It looks like it happens at about 10. So it looks like P of 30 is approximately 10. So 30 years after 1950. So that'd be in 1980. And 10 is the number of people in town in thousands, so 10,000 people. So in 1980, there are 10,000 people in town.